Welcome friends, today we'll make a free energy generator using a cylindrical syringe, copper coil, magnets and DC motor. For this we will take an insulated copper wire of maximum length and then take a cylindrical syringe. You can use any other cylindrical object also. Here I am taking a cylindrical syringe. Next I'll remove the piston of the cylindrical syringe. I'll remove the piston of the cylindrical syringe. Next, we will introduce a round magnet inside the syringe so that proper insulation can be done without any removal of the insulation wire. Next, I'll take a insulated copper wire and wound a maximum number of turns over this syringe so that a maximum flux will be linking with the coil. I'll make a tight winding over the cylindrical syringe so that a maximum number of turns is there. As we increase the number of turns of the solenoid or the coil, the flux linking with the coil is maximum and maximum energy is produced. One by one we can make the winding over the syringe as much as possible. By tightly holding the syringe, we have to maximize the number of turns over the syringe. So we will increase, tightly holding the syringe, we will increase the number of turns over the syringe. So you have to see that all the windings are tightly held. After finishing the winding, we have to fix the endings of the winding with the glue or insulation tape. Once it has been completed, we will fix it with a glue or a insulation tape. Here I am using an insulation tape to fix the endings of the coil. Once it has been done, next we will take an insulation tape and fix the endings of the wire. By taking the insulation tape, we will fix it properly so that the endings of the wire will not be removed. We will fix it tightly with the insulation tape. After fixing it properly, we have to make it stand vertically over the cardboard. So we have fixed it, and after fixing it, we will remove the insulation of the front endings of the coil and make it stand vertically over the cardboard. Using any type of glue or adhesive, we have to make the syringe stand vertically over the cardboard. Once it is been made to stand vertically, next we will bring a bigger magnet so that we can mount a DC motor over it. So we will bring a bigger magnet, and before that we will arrange a glue or adhesive to fix the syringe tightly over the wooden board. So once the adhesive has been ready, we will fix the syringe in such a way that it will not move here and there and tightly fixed on the cardboard. Once the syringe is fixed tightly, next we will bring a DC motor with a front magnet so that we can bring the magnet as near as possible to the windings or solenoid of the syringe. So we will fix it properly, the motor with a glue or any adhesive. We will paste the adhesive over this big magnet and fix the DC motor in such a way that the magnet is very near to the coil so that maximum flux will be linking with the coil. Once it is been done, next we will take a diode so that we will fix it in a forward bias so that whenever the AC is generated, we have to convert it into DC. We will solder the diode in front of one endings of the coil. Properly solder has to be done. So once the solder is been done, the diode to the one ending of the copper coil, we will fix a filter capacitor in front of that so that we have to filter out the residual AC in the coil. So we will fix a diode in front of one ending of the coil. After fixing a diode in front of the coil, next we have to fix a filter capacitor in front of in parallel to the coil to both the endings so that the residual AC in the coil will be removed while the generation of electricity. So once we will fix the capacitor to both the endings of the coil in such a way that whenever the AC electricity is generated, it can be converted into DC by filtering out the residual AC in the coil. Once we have fixed the capacitor, once the capacitor has been fixed, now we have to fix the extension board to the endings of the terminals of the coil so that we can get the output of the energy or electrical energy. We will solder it properly to both the endings of the coil so that a proper solder is been done. Both the endings of the extension board are properly soldered to the endings of the coil. Once all the soldering is been done properly, next we will have to fix the output of the extension to the motor so that the loop connection will be finished. Now we will take the input to the DC motor with the extension board. Once the connection is been completed, we will fix it tightly in the extension board so that the total circuit or a loop connection is finished. Then we will give a turg to the pulley of the motor where magnet is connected. The maximum turg should be given so that the magnet rotates, and once the magnet start rotating, the EMF is built, and normally the magnet starts to run continuously. You can check here the EMF is generated in the coil with the DC bulbs glowing, showing that maximum EMF in the coil is generated. This also works on the principle of Faraday's law of electromagnetic induction, stating that whenever the flux linking the coil changes, EMF is generated in the coil. Next, we will solder the DC bulb in front of the coil to one end to the diode and another end to the black wire so that the DC input is given to the bulb, and the bulb glows brightly, showing that EMF is generated in the coil. When the magnet rotates in front of the coil, EMF is generated and we'll get output of DC. Here you can check the bulb glowing. Thank you friends. Please subscribe the channel and press the bell icon. When I are making such type of video, you will get the notification. Thank you very much.